Hi, this is Mr. Manley. In this video, we are going to look at how to find the value of a trigonometric expression using the unit circle. In the past, to find values of trigonometric expressions, as you learned in geometry and maybe even an earlier trigonometry course, you used SOHCAHTOA to be able to find the value of a trigonometric expression. But SOHCAHTOA only works if we have a right triangle. And here with this angle, maybe you know, that's more than 90 degrees. So I can't even find that angle in a right triangle. This is where the other trigonometric equations come in, or another approach to what the trigonometric expressions mean come in. Now here we have what you know from the past. This is an equation representation of SOHCAHTOA. What we're going to do with the unit circle is say that any point on a unit circle, which I have placed on an xy axis, so I've got the x-axis and the y-axis, any point on the unit circle will have an x-coordinate and a y-coordinate. The unit circle also has a radius, right? That radius r. For a unit circle, it's always 1. Now, we could be working on a trigonometric circle that does not have a radius of 1. So we'll just leave it general as a radius of r, understanding that whenever we are working on a unit circle, the radius r is equal to 1. Now I'm going to use these three variables here, x, y, and r, to make new equations for what each of the trigonometric expressions mean. Sine of theta is y over r. So instead of needing an opposite and hypotenuse in a right triangle, we're going to take the y from the y coordinate, and we're going to take the r from the radius, which again, if it's a unit circle, the radius is 1. Continuing, cosine theta is x over r, and tangent theta is y over x. We also have the reciprocal functions, which I want to address as well. For the reciprocal functions, I'm just going to look at the x, y, and r. And maybe we know already that cosecant, for instance, is the reciprocal of sine. So taking that into account, maybe you can tell that with an x-y-r definition of trigonometry, I would say that cosecant theta is r over y. Secant theta is r over x, and cotangent theta is x over y. One other thing I'd like to point out about this is, for each of these reciprocal functions, so looking at sine and cosecant, since they are reciprocal of each other, I can make another statement as well that can sometimes be useful. I can say that since sine of theta is the reciprocal of cosecant theta, I can say that the sine of theta is equal to 1 over cosecant theta. We'll look at that for a moment. And then consider, I could also say that the cosecant of theta is equal to 1 over sine theta. And this is an equation that you may find useful in certain circumstances. Likewise, I could do the same for any of these other functions. For cosine and secant, I could say that the cosine of theta is equal to 1 over secant theta, and so on, going down the line. Having established that, it's very easy to evaluate any trigonometric expression if the angle is actually on the unit circle, which of course we only have a certain number of angles that are convenient to us, that are on the unit circle. This one, of course, is sine of 2 pi over 3. If you have a unit circle to look at, you could find the 2 pi over 3 on the unit circle, and you would also have, with the 2 pi over 3, the xy coordinates of that point where the angle intersects the unit circle. So to evaluate sine of 2 pi over 3, I simply find 2 pi over 3 on the unit circle. I consult my list of definitions of the various trigonometric values. Here I'm looking at sine theta, y over r. So that means I want the y coordinate, and r, which for a unit circle is 1. So the y coordinate here is rad 3 over 2. Sine of 2 pi over 3 is rad 3 over 2. And then of course over r, which is over 1, which doesn't affect that value at all. Looking at another one, here I have the cotangent of 23 pi over 6. Now 23 pi over 6 I do not have on a unit circle, but I see that this is a multiple of pi over 6. So let's take a look at finding the angle that is coterminal with 23 pi over 6. A couple of ways I could do this. I could write 23 pi over 6 as a mixed number, which in this case would be 3 and 5/6 pi, which on a circle would be starting at 0 on the positive x-axis. I would rotate 1 pi, 2 pi, 3 pi, and then another 5/6 is going to put me there, which on my unit circle will be listed as 11 pi over 6 with the coordinates rad 3 over 2, negative 1/2. Just one other thought about finding the point on the unit circle. I could also take the 23 pi over 6 and subtract 2 pi until I get a value that is between 0 and 2 pi, which would put me on the unit circle. Common denominator, 6 over 6. 23 pi minus 12 pi over 6 would be 11 pi over 6. So I could get there that way as well. Now I've got my angle on the unit circle, and I have the point associated with that angle. Consulting my definition of cotangent theta, I see that cotangent theta is x over y, and I've got my x and my y here. X rad 3 over 2 over y negative 1/2. It would be nice if you simplified that to negative rad 3. And that is the use of the unit circle to evaluate trigonometric functions, as long as we have these definitions, the x, y, r definition of each of the trigonometric functions.